Alright everybody, I hope you're well and I hope you had a good new year. What I'm going to try and do in this video is a short beginner's guide to debugging in Altirra, which is the excellent Atari emulator by Avery Lee, also known as Fearon on the Atari Age forums. I encourage you all to download it. What I'm going to use as an example here, these videos, bear in mind, are traditionally very difficult to make because of all the switching I have to do between two desktops. I've zoomed everything in here, which looks awful, but it's just so you can actually read it on the screen without having to have the video on a huge full HD display. So what I thought I would do is use a real-world example of a bug I discovered the other day, which I was very pleased to have discovered just at the nick of time, and walk through the steps to discover what was causing the bug, what the problem was. I'm sure other developers will have much better and much more efficient ways of doing this. I know that Avery himself has all sorts of fancy features that he keeps adding to the debugger, which probably make my methodologies seem very clunky and awkward, but nevertheless this is the way it is, so I'm going to show you what I did. So when I noticed this, what I was trying to do on the day in question was demonstrate on video, videos being an excellent way of exposing bugs, demonstrate on video flashing the ultimate 1 megabyte firmware directly from the FAT partition of a compact flash card. Now we can do this in a couple of ways, but I was doing it by launching the flashing tool from the loader directly, and of course the loader has a full read-only FAT file system driver built into it, and I wanted to demonstrate this because someone also asked about updating the firmware this way, and the file wouldn't open. And this of course was most unexpected because I was absolutely sure that it did work previously, so it looked like I'd introduced a new issue. So I came back to the PC with an identical setup, identical firmware and everything, and came back to the PC to see if I could track it down, and I did manage to track it down in about 10 minutes, and I'm going to show you what I did. So if we go over to the Altirra screen, if we're not already there, hopefully I'm on the right monitor. Now, well, I'll close the debugger down for a moment. So this is where we are. So I'll show you what I was trying to do. So I've run I'll go back to the start. So we go into the loader. I had to use the 1088 XEL machine as well, because it's the only way that the firmware triggered in this exact way. Actually, if it oddly enough on a stock ultimate 1 megabyte machine, the equates are sufficiently different that if I'd noticed the bug on that platform, it would have been much harder to track down actually. But in any case, this is what happened. So we launch UFlash straight from the loader, cursor down to firmware, press enter. And of course we can navigate the FAT directory structure here if we want to, but we're in the correct directory already. And we press enter on here. Firmware, is this the file you want? Absolutely right, no problem at all. Here we go. Oh, can't open file. What on earth? What on earth is the reason for this? So that's strange, isn't it? So we appear to have a bit of an issue. So the first thing to do, of course, is to open the debugger. And you open the debugger, you can either press F8, which will stop the emulated machine and open the debugger, or just open it. That doesn't stop the machine from running. So what we need to do here, if we look again at the sequence of events, We open the file, everything looks great, and then it says it can't open. We need to stop the emulated machine just before we get this error message, this error dialog up on the screen, because by the time we get to this point, the actual events pass by. You know, it'll be way back in the execution window. Now I'll just take you on a quick tour while I talk about these things of the different things I've got open on the screen. As I say, bear in mind these are all zoomed in. We've got the, I'll stop the emulated machine here. I've got the console here at the bottom. This is the layout I like. Oops. I've got the console at the bottom. This is how I like things to be. So this is where you type your debugging commands. I mean, we can have a look at the state of the emulated Ultimate 1 megabyte here. We can do all sorts of other cool stuff. If you press .help, Altirra gives you a lovely list of all the debugging commands that you can issue here. Quite a long list. And if you type help, and so let's pick a command that we want to understand a little bit. Let's pick watch byte, let's for or BP, whatever, breakpoint. Okay, so if you type help and then the name of the command that you want to read the help about, it gives you a nice little précis of all the usage. Set a breakpoint at PC address. It gives you examples, and this is pretty much how I used to learn to use the Altirra debugger. It can, I mean, just reading this stuff, it's incredibly versatile. It absolutely it sets the bar pretty high for an 8-bit debugger. It's really remarkable. So you can use this the console to explore the debugger, all the commands, all the built-in help. That's all wonderful. Now if we move up here, obviously above this we've got the display itself. Now I've got capture mouse pointer on there. I'm better. Capture cursor, yes I have. Okay, so obviously I've got the emulated machine open here above. Obviously I've pressed F8, I've stopped the machine now. Now these two memory windows here, which are, as I say, are zoomed in, so they look really awful, unfortunately, just so you can see what's going on. Well, that's annoying. These I have two of these just pinned to the corner of the application. I find it very useful just to have two memory windows on a sort of a pane like this. Just tiled, so you can, let's see, I wanted to look at the DCB, the SIO device control block at hex 300. There we go. So this normally I've got it zoomed out to about 7.5 point text, so you can look at all the registers here, all the memory locations rather. I find that very useful. Now I've got some tabbed stuff along the bottom here. I've got the history window, which shows you a fairly long history of all the recently executed instructions, and we've got, it's, as I say, it's very difficult to navigate this. I mean, it's absolutely marvelous. It's you can open up. It's all sort of folding. So we've got a vertical blank interrupt that happened here. We've got scanline counters and things that we can collapse this a little bit more actually. Might fit on the screen a little bit better. Show special registers. That's a bit better. We can see a little bit more of what's going on here. So yeah, we see a VBI happened here, and we can trace right back through what we've been doing. And your breakpoints, when you set them, will show up in this window as well. So it's very good. Now we've got disassembly as well. which is marvelous because now that's folding, and we can expand subroutine calls just by clicking on this. And you can disassemble anything you want, so we could disassemble, I don't know, CIOV, the CIO entry point, if you wanted to, so we can expand on that, what happens when it goes through that jump. Marvelous. And then I've got the registers set up here. I just find that quite handy. I hardly ever use this actually, but it's there if it's needed. So stuff that you don't need to see all the time, you can tab it in the corner. I mean, these windows, when you first open them, they usually float, but if you pin them down here like this, and they're back to front now, you just drag into the square, and that will tile the. I don't want to tile them, do I? I want right. So if you drop it on the arrow, it'll tile the window, and if you want tabbed stuff, you just drop it in the middle of the square, and it becomes a tabbed window. So that's the components I've got open. So what do I want to do here? I want to know now. Obviously, when this application opens this file, it's doing through the CIO, through the standard methods that applications use to open files on the Atari. So we don't really want to know the state of the machine when it went into the CIO, but we want to know the state of the machine when it came back out again. Well, we can do this. So if we restart the emulated machine, clear this message, we'll go to just before, so we'll run through the process until we get to where we think the next CIO call will, when it returns, trigger the error or reflect the bug, if you like. So we're going to open the file. So it's asking us now, do you want to flash this file? So I think the next CIO call is probably going to be the open file, and that's where it fails. So we want to set a breakpoint right here. So I'm going to just say BP CIOV, which is E456. So the machine's going to stop as soon as the application calls the CIOV. So we're going to have press enter. So we'll restart the machine and press F8 again. So the machine's running again. The emulated machine's running again. I'm going to press enter. And there we go, straight away we've got a breakpoint triggered on CIOV. Now the thing is, if we look in the corner here, this actually isn't what we want to look at. And how do we know this? Because the code, the command stored in ICCMD, which is the command register for the IOCB, is 12, which is closed channel. So obviously this program, before it opens the file, it first closes the channel, which doesn't do any harm. It just ensures that IOCB is shut. So this isn't the call we want, but the next one probably is. So I'm just going to press F8 again to restart the emulation. So just going to continue. You can also press G here at the console if you want. So we press G, which is going to go straight to this breakpoint, keep going. Now we've reached the next one. Now this looks a bit better because if you look here, we've got the open command, which is 3, which is being stored in ICCMD. So this looks very, very encouraging indeed. This does look like what we want. But the thing is, we're going into the call now. We're calling into the file system. This is not what we want. We want to see what happened when it came back out again, when it said that it couldn't open the file. But if we look here, we are actually in we're in a higher level subroutine. So this code here, which starts at 92F2, sets up the IOCB, and then it jumps into CIOV. It doesn't JSR into it. Now, why would it do that? Well, the reason is that because it's kind of a cascading JSR, if you like. I forget what the actual term is. Somebody correct me. But the thing is, this is gonna end in an RTS anyway in the operating system. So it's the exact same effect as if we'd said GSR. Rather, if we'd said GSR CIOV and then followed it with an RTS, we can just replace those two. A GSR followed by an RTS, you can replace it with a jump, which is exactly what I've done here about 5 or 6 years ago. So we can't put a breakpoint down here because there's no RTS to catch. So we're going to look further up. Well, this routine at 92F2 is itself called by a GSR 2115. So if we look at 2115 in the disassembler right here, we can see that 3 bytes, the GSR instruction with the address is 3 bytes long. Aha! At 2118, 3 bytes higher, we've got a BPL, which means if the negative flag is clear, we branch to whatever we do when everything's okay. So if the file opens successfully, we branch to 2130. But if it's not, if the negative flag is set, we do some stuff here, which presumably opens up that error dialog. So where do we want to set our breakpoint? We want to set it at 2118. So I'm going to set a subsequent breakpoint. I'm not going to clear the original one. You can set more than one breakpoint. I'm going to set another breakpoint at 2118. Okay. And I'm going to press G again, and I'm going to let this whole thing run through, and then it's going to stop when it comes back out of the operating system CIOV code. So if we look again at the history window, here we are, 2118, and we've got all this code here. There's where we jumped into the CIOV. So at this point we're in the context of the operating system itself, which immediately jumps to a different address. And somewhere in here, the file system that I wrote for the loader is called. Now we can find out where that is by opening up these collapsed folded areas of code here. So you see here, now this code here, this what does this do? This sets up some pointers. What's this doing? Well, I mean, if you cascade through these, well, this looks familiar. Now we're looking for an address that is really, really low down in RAM, because that's where DOS usually is, and this is basically a little DOS. So here we've got the operating system has loaded into it's loaded an address, pushed it onto the stack, and then done an RTS, which is like an indirect GSR, and it's ended up as OAC4. Now this, if I'm not mistaken, is the code. This would be the entry point for the open command of my CIO handler. So we're in the right place. So somewhere in here, something goes wrong. And it doesn't take long, actually, to see what goes wrong here. So we're in, we've got page, this is page 10 of memory. This is page 11 of memory. Now we've got page 13 of memory, rather, OD9E. So this, you wouldn't expect the file system, you wouldn't expect DOS to start calling code that was outside of, anywhere above 1 FFO in hex. Now what do we see here? We've got code at 3635 being executed by a jump from ODA9. What the hell is going on here? And copying data from this address, and then it comes back down here. So what on earth's going on? That I can immediately see that that should not be happening. Now, what I find useful here, now, one thing I haven't got, which I'm going to get absolutely slated for this, is I have not yet set up source code level debugging in Altirra. And you can do that. I've got into this awful habit of just doing things this way. So what I've got open here is the assembler output is the assembler output from the MADS assembler, which has, of course, all the addresses, all the equates in the program. And I was always in the habit of just using this output listing when I was using debuggers, and I've just continued to do that. So I do apologise for not using source code level debugging, but I do a lot of ROM based stuff as well, and I'm quite sure that it's possible to also handle banked ROMs using source level debugging, but I haven't gotten around to it yet. So yes, that has to be on the list. I'm sure there's a much easier way to do this, but nevertheless, what I'm going to do here is I'm going to look to see what on earth is at address 3635, which is the address of the code that was being called by the file management system in the emulator. So if we go down here, search, just done a search through the file, and what do we have here? I'll say ignore these comments because I had to set this up especially for the video. The problem is already fixed, of course, so I had to unfix it for the purpose of this video. But what we've got here anyway is some code. It's called setup sector pointer. Now, as you can see, it's obviously part of an open file routine. It's not part of the file management system because it's way up in memory at 3632. And if you ignore these commented out parts, what happens here is that we get entry cluster info is code which I happen to know it's code which extracts cluster information from the entry, the highlighted entry in the fat file browser menu of the loader. And that falls into, so it executes that, and then it falls into this routine here to save space. It just falls straight into this, so it executes that, and then it comes straight through here. And this just sets up a couple of pointers, stuff to do with file lengths and things like that. Sets another flag, clears the EOF flag, and then it jumps off somewhere to get to translate the cluster number into a raw sector address, and then does who knows what. Now, what appears to have happened here, because this bug didn't exist in the previous release version of the firmware, but what I did do, because a lot of this code here, some of this stuff further down, was way down at the bottom of memory, and I realized when I was working on this version that it was the memlo, the low memory limit for any file that you loaded, for example, would be better if this code, if it didn't absolutely have to be at the bottom of memory, it would be better if it was higher up, because all this gets cleared out by the loader. When you load an XEX file, all this stuff gets zeroed out. The loader completely removes itself from memory. Now you can see an immediate problem here. Now that's all well and good if this is the only place that this code gets called. It's going to get destroyed, wiped out of memory, no problem at all. But so setup sector pointer, is it called by anything else? And it is. What's fallen into? Well, yeah. And it is. As I say, ignore these commented parts, if you will. This was added later on. Now, this, as you can see by the addresses here, this is way down in the file management system that gets installed at the bottom of memory. And what do we have here? Ignore these conditionals. This is so does this code get called by anything else? So let's have a look. And it does. So here we are. I've had to edit this listing a little bit if you notice some missing line numbers, but please bear with me. So this same routine setup sector pointer is called by the file management system, which is way down at the bottom of memory here at ODA9 calls that code. Well, this is a disaster, of course, because by the time this code executes, there's an application in memory that's been loaded into memory by the side loader, and it wants to access the disk, but all the upper area of memory has been cleared and probably overwritten by the application itself anyway, and yet here we are, we're doing a jump right into 3635. So what happened here is that I moved a piece of code which I should have left at the bottom of memory. So the fix for this, of course, was to put it back down at the bottom of memory, actually, so I can... So the fix for this, of course, was to put this code back further down at the bottom of memory. So the fix for this, of course, was to put this code back at the bottom of memory, which I did. So if I can actually undo this stuff that I changed. So I changed it so that the code higher up in memory jumps to this code. I've removed this from here. I just kind of commented it out. So I can save that again now. And then over here in the file management system area, so this is the code that's very low down in memory. I moved this code down here, where it can still be called by the other code higher up in memory, but it's safe from being obliterated, and it didn't take any extra room either, because now if I put this immediately after this code which calls it, I can now fall straight into this one as well. So it ended very nicely because the code didn't get any bigger because of the fix, basically. So there we are. So that's hopefully I've redone the fix on these source code files. So we can go ahead and compile this again. And what I've done here on the emulator, which I did just before I changed the camera view, is I've cleared all the breakpoints. That's easy to do, just type BC. You can either clear a breakpoint via number, the rounded bar, just set another breakpoint here. Right, so, and you can list breakpoints with BL, and you can clear breakpoints by BC and the number of the breakpoint, or you can clear all your breakpoints with BC star. So we had one breakpoint, now it's been cleared, so we have no breakpoints left. So if I restart and continue the emulator, we'll come out of this and we'll flash the, if you notice things going by very quickly, by the way, I've got, in the emulator, I've got the habit of holding F1. This speeds the emulator up into turbo mode, and there's no need to wait around for things to happen. So anyway, I'm going to go into PCL2, I'm going to load UFlash with the F1 key held down, which is why it was so fast. This is the way I work, and it's very quick. It's quick for me anyway. Now I'm going to replace the loader with the version that I've just fixed. There we go, flash that. F1 through that as well. Okay, so that's been updated. Now if we go back Now if we go back here, this whole operation should work this time, hopefully. So we're in UFlash again, we'll come down to the firmware slot. This is actually the wrong firmware file, so it's actually the ultimate one, the stock one, but it doesn't matter. So now we select the file as we did before, opens, flashes, no problem at all. So that's how I discovered that bug. Actually, it was a little bit easy actually, because it was so obvious what was going on once I started to disassemble memory. But I didn't want this video to be too long, but it just gives you a little idea of what you can do. It would take forever to go through this debugger in Altirra and show you all the different things you can do. I mean, you can... I'm going to have to undo this now, actually. It would take forever to go through Altirra and its debugging facilities and show you everything it can do, because it's just enormous. I'm trying to think of the other things that I use quite often. You might want to, for example, set a breakpoint on an access to a memory location. That could be rather useful. So I might want to set a breakpoint on any writes to the let's see, any writes to the SPA.SX banking register, let's say. So that would be D5 EO. Okay, so breakpoint 0 set on write at D5 EO. And I can immediately trigger that if we go back into the emulated machine. And if I just do a DIR, there we go. SPA.SX has immediately hit the banking register because it's switching ROM around just when I've typed a DIR there. Probably because it's loading the directory command or the... I think, is it DIR an external command now? Possibly. I think it might be. But anyway, so that triggered access on that register. I'll clear that one now. BC clear. Likewise, we can do the thing with a read on an address. So we can break access read D5EO if we want to. Well, that's actually a write-only register, so I don't know if that'll actually do anything. Yeah, so that's a write-only register, so nothing's going to bother reading it, and obviously it doesn't. So it's not a great example. And if it gets a little bit more complicated, what happens if you wanted to, for example, let's say you wanted to see if... So let's say you wanted to know... You wanted to set a breakpoint when a value greater than 20 was written to the banking register, let's say. Well, in that case, you could say bx, which is break on expression, write equals .d5eo, and value is greater than or equal to $20. Okay, so whenever a value of which satisfies this condition is written to here, we should get a break, and that should be relatively easy to trigger as well if we just go into the BIOS, I think. There we go. So we try and run the loader from the BIOS. The loader exists in a higher bank than the main BIOS menu. So we immediately got a write. We immediately triggered that breakpoint. And to be honest, every case is different. There's more esoteric, complicated bug hunting. It can get incredibly complicated and time consuming. That was a very, very easy one. But that just gives you a, if you're just trying to debug your first program in the emulator, that hopefully that gives you a little bit of an idea of how to do the basics. So just to give you an idea of how to actually set up these windows in the debugger, I've closed all of the panes I've got, and I'll set them all up again. I can't actually remember what the default state of the Altirra debugger is when you first open it on a virgin installation, if you like, but I'll show you how I set mine up. You get at these window options through the debug menu here, and if you click on the type of window you want, it opens it up in a default position. Now your layout might be different to mine, and almost certainly will, but we'll go through it. So we can see just by clicking on a given component we get the window. So I want two memory windows here. I want 1 and 2. So we go into here and select the second one, and I also want a history window. As I say, these may appear in default positions that are different just because of the way I've been messing on with things. Yeah, but you can see they've appeared in all sorts of weird positions. This is not where I want them, but I'm going to get them all on the screen and show how I would arrange them. Disassembly and call stack, which I never look at, but we'll put it there as well. So here we are, we've got all the windows we want, but all in the wrong place. So I want the, so if you pick a window up by the title bar and start to drag it, you get all these drop zones. Now the middle square part in the middle of the diamond, that will give you a tabbed layout next to what's currently there. So if I drop that there, we've got it's tabbed next, the console is tabbed next to the window that it was actually hovering over. I don't want that. And what I want is to put the thing underneath the display of the emulated machine. So I'm going to drop it on the bottom, so these 4 arrows indicate where in relation to this window this one's going to end up. So that's now in the correct place. Now I want the memory windows to be tiled next to one another, so I'm going to place this one to the left of this one, so the memory window's in the right place now, more or less. I want the history underneath, so I'm going to drop it here. We'll worry about this in a minute. And then the next one, I want the disassembly to be tabbed next to history, and then I want the call stack to be tabbed there, and then I want the memory window 2 to be to the right of memory window 1. You may have to experiment a little bit here. I want to put this on the top, and I want to put this one next to it, and it isn't doing what I want. That's fun, isn't it? Yeah, it's lots of fun, lots of fun. So put this underneath here. Oh shit, this isn't really going very well at all. Let's see now. Put that there, and put that there. That's nearly right. There we go. Right, finally. So as you can see, you have to drag things around a little bit to get them right. And obviously I'm going to extend this. The font size is much bigger than I'd normally use, so you're not going to be able to see everything the way it should really be. I have things more or less like this. So if you can click into what you want to look at. So that's if you open the debugger and things are all over the place and you don't know how to get things looking like this, or however you want things laid out, that's how you do it. So debug and window, and then arrange things exactly how you want. Thank you for watching this one, and I'll be back shortly with another video talking about the firmware. Got some interesting news on the kind of side front and Ultimate 1 MB front and things like that, so stay tuned for that one, and I will see you in the next video.